In this lesson, we will be evaluating algebraic expressions. Example 1, evaluate a squared minus b squared given a is equal to -5 and b is equal to -3. Now the key when evaluating algebraic expressions is to pay attention to the negative signs. As we learned in a previous lesson, there is a big difference between -5 squared and -5 squared without the parentheses. Remember, -5 squared within the parentheses would give you a positive result, whereas without the parentheses the result would be negative. So you want to make sure you pay attention to the negative signs when you evaluate this expression. So our expression is a squared minus b squared, and what we want to do is replace a with -5, b with -3. Now in order to do this, as a general rule, always use parentheses. Always put parentheses around the value. So here we are replacing a with -5, so I'm going to put -5 in parentheses in the place of a and write the rest of the problem around it. Squared minus, and do the same thing with b. b is being replaced by -3 inside parentheses, and then that is also squared. Now this becomes an order of operations problem. Exponents first. -5 squared, this is -5 like we have up here within parentheses, so that's going to give us a positive 25. Minus, that minus sign stays put, -3 squared. Again, the -3 is inside the parentheses, so it's going to give us 9. Now we can subtract. 25 minus 9 is 16. Example 2, evaluate -a squared minus parentheses b minus c. A is equal to -5, b is equal to 4, and c is equal to -2. I'm just going to recopy this down here on my paper. And we're going to do the exact same thing. We're going to replace each letter with the corresponding value and being very careful with the parentheses. So beginning here, we have this negative sign is going to stay put. What we are replacing is just a. A becomes -5, put that in parentheses, copy down the square, minus, parentheses, now b. We're replacing b with 4. I'm going to go ahead and put that inside parentheses, minus c. We're replacing c with -2, so I'm going to put in a little set of parentheses here, close those parentheses. Now it becomes an order of operations problem. This is equal to, beginning with the exponents, this first negative sign is going to stay there. We're going to just evaluate the -5 squared, which will be 25, minus, copying down the rest of the problem, there's the 4 minus -2. Now, working within the parentheses, we have, there's our -25 minus 6 equals -25 minus 6 is -31. Now example 3, we have an application problem, and you are going to see a lot of these in this class. You need to know how to work with them. During exercise, the recommended maximum heart rate in beats per minute is given by the formula m is equal to 0.8 times 220 minus a, where m is the maximum heart rate and a is the person's age. What is the maximum heart rate in beats per minute for a person who is 40 years old? Now, in order to start this or any other application problem, you want to first look at what is given in the problem. You want to make sure you understand what is given before you try to figure out what the answer to the question is. So given in the problem, first of all, is the formula. M is equal to 0.8 times 220 minus A. And also part of the given information, you always need to know what the letters represent, what these variables represent. M is the maximum heart rate, and A is the person's age. You really want to make sure you keep straight what the letters represent. Now, after you've identified the given information, you need to know what the goal of the problem is. A lot of times the goal of the problem will be the question that is asked. So in this case, what is the recommended maximum heart rate for a person who is 40 years old? That is the goal. That is what we want to find. So after we've identified the given and the goal, we need to form a strategy. For this particular problem, we're given a formula and we need to figure out what is the maximum heart rate for a person of a given age. So our strategy is going to be to evaluate the expression. In this case, m is equal to 0.8 times 220 minus a, given a is equal to 40. And if you notice, this is a very similar problem to examples 1 and 2 above. Now, to solve this, we simply evaluate the expression for the given value. So down here, I'm just going to copy down m is equal to 0.8 times 220 minus a, and replace a with 40. So m is equal to 0.8 times 220 minus, replace a with 40. M is equal to 0.8 times 220 minus 40 is 180. 0.8 times 180 gives you 144 beats per minute. So we have our answer. M is equal to 144 beats per minute. Now, you always want to perform some sort of a check whenever you are working with any mathematical problem, particularly an application problem. And the check can take several forms. One way, you want to ask yourself, does your answer make sense? Does it seem to be reasonable? All right, just look at the problem, look at your answer, and just ask yourself, does it make sense? You also want to go back and check any calculations that were made. After you do that, you can be pretty confident that the answer you have found is the right one. Now, your last step is to interpret your answer. Your final result always needs to be written in a complete sentence. So here, the recommended maximum heart rate for a person who is 40 years old is 144 beats per minute.